Okay. So page 1, problem number 1 here. There's 2 important things that I want to be looking at. Sorry, that was not supposed to zoom in for you guys. Let me fix that. 2 important things that I want to look at and pay attention that give me useful information. First thing I look at is my leading coefficient. In this case, because it's a monomial, this is my leading coefficient right here. I'm actually going to write that down where it says leading coefficient. That's a 9. Is that leading coefficient a positive or a negative number? Is that leading coefficient there a positive or a negative number? It is a positive. And so what that tells me is that the right side goes up. Well, it's telling me about end behavior. If it's telling me about the right side going up or going down, looking right here for end behavior, which one of those is telling me about the right side? Because I know now from that leading coefficient that the right side goes up, but I don't know which one of these statements is telling me about the right side. Would it be the first one, the one on the left, as x arrow negative infinity? Second one, yes. X arrow infinity. This information right here would direct me to the right side of the graph because that is where the positive numbers live on the x-axis. So what do I put on that blank line? As x arrow infinity, so the right side of my graph is doing what? What number or symbol should I put on this line right here? What did we just say the right side of our graph was doing? Positive infinity, yes. Because that's how I say it is going up. Beautiful. All right. To figure out what I'm going to put on this other line for my end behavior, I need to figure out what the left side is doing. To figure out what the left side is doing, this is where I look at my degree, my biggest exponent. Biggest exponent is the degree. Since I just have a monomial here, that means that we have a degree 7. So a couple key important pieces of information when we're talking about our degree. If that number is odd, then my ends are opposites. If that number is even, then my ends go in the same direction. Which one of those cases do I have here? Is my degree odd or even? Odd. So we're looking at this situation here. So what should I put on this line? We said our ends are going in the opposite direction. So I'm going to have a negative infinity over here because that is the opposite of what I put over here. Opposite of the right end behavior. Again, we know this guy right here means left. All right, we've got 4 of these 7 pieces filled in here. Since I have a polynomial, my domain is always going to be the same thing. Anytime we have a polynomial, my domain is negative infinity to positive infinity. For the range, this one kind of depends on my degree. So I'm going to make a little note down here. If it is odd degree, my ends are going to be pointing in opposite directions. So will I have a highest point? If my ends are pointing in opposite directions, will I have a highest point? Nope. Will I have a lowest point? Also no. So if it is odd degree, it will be negative infinity to positive infinity. If you are even degree, meaning your ends are going to go the same way, you're going to want to look at the graph. Because it is either going to be your minimum up to infinity. That'll be if it has a lowest point. Or if your graph has a highest point, it'll be negative infinity up to your maximum. But I'm going to need to look at the graph for that one. Do we need to look at the graph on this one? Do we need to look at the graph on this one? No. So what is my range? If I don't need to look at the graph, what is my range? What would I write down for the range here? Negative infinity to positive infinity, yes. All right, we have almost everything filled out here. We have just one more piece that we need to talk about. And that's this part right here. What is the value of the function when x equals 3? So what they're telling me to do is sub 3 in for x, and then we're going to simplify. So f of 3. I don't do anything with this value right here in this part of the function rule. That's just telling me what I'm substituting in for x. So substituting 3 in the place of x, multiplying it by 9 and taking it to the 7th power. Which one of those two things would I do first? Do I multiply it by 9 first, or do I take it to the 7th power first? Think about your order of operations. Think about PEMDAS. Do I multiply first? We're going to take it to the 7th power first. So grab your calculators. I need to know what 3 to the 7th power is. $21.87, yes. Now take that answer and multiply it by 9, and that will be our answer here. Multiply those two together. $19,683. That is what I want right here. 19,683. Beautiful. We have exactly 10 minutes left. I don't want to look at number 2 because number 2 is very, very similar to number 1. Do you guys want to look at number 3 with me? That's similar to this one. It's enough different that I think it's worth looking at. First thing I notice about this problem is that they tried to get tricky with us. What is the degree? What is the biggest exponent? Yes, biggest exponent is a 4. That leading coefficient that I go looking for, this is the coefficient on X with the biggest exponent. So I'm not looking at the very, very front. Here's X to the 4th. So I'm looking right here. You're absolutely correct. This is going to be 8. Beautiful. When they've tried to get tricky with us, a lot of times it's very common to rewrite this in decreasing order so that that leading coefficient really is up at the front. 8x to the 4th minus 4x cubed minus 7x squared plus 6x plus 7. A lot of times people will rewrite it in that order. All right. Let's talk about our end behavior. Tell me what the left and the right side are doing here. What are the left and the right end doing? First of all, are they going the same or opposite ways? Let's start there. How do I know? Same or opposite ways? Same way. Where do I look to know that they are the same way? Look at the degree. Yes. If this number is odd, then they will be opposites. If this number is even, then they will go the same direction. And since 4 is an even number, I know they're going to go the same way. Are they going up or down? I know it's going to be the same thing on both lines. I just don't know whether to put a positive infinity or a negative infinity. Where do I look for that information? Up. How do we know? What did you see that you knew they were going up? I absolutely agree. That is correct. Positive leading coefficient, this one right here. Positive number. This only tells me about the right side. But we knew from the degree that they were doing the same thing. So once I know the right side's going up, I know the left side has to go up also. What is my domain? Remember, domain is the same for all, there you go. Domain is the same for all of our polynomials, negative infinity to positive infinity. Do we need to look at a graph for the range here? Yes. So I'm going to go over to Desmos and we're going to type this in. We're going to look at that graph. All right. So I have 8x to the 4th minus 4x cubed minus 7x squared plus 6x plus 7. Scoot this down a little bit. There's our graph. Does that graph have a maximum or a minimum? Has a minimum. So I'm going to start with that number. I'm going to zoom in a little bit on this minimum. Yeah, I'm going to leave it about right there. Ballpark that minimum for me. We're not going to be able to get exact with this, but ballpark, about where is that minimum? About how low? About 2.7. Yeah. Right, so when I'm writing range, I write the minimum first. This one has a minimum, it's at about 2.7. What would I put after the comma? Normally that's where I put the maximum, but what did you notice about that graph? What would I put for the maximum? Positive infinity, absolutely correct. All right, last thing we need to do on this, they want me to substitute in. They want me to sub 5 in for x. And that means absolutely everywhere I see an x, I'm going to replace it with a 5. Remember, in my function notation, that just shows me in case I forget what I'm substituting in the place of x. So I have 8 times 5 to the 4th power minus 4 times 5 to the 3rd power minus 7 times 5 squared plus 6 times 5 plus 7. All right, order of operations says I have to do the exponent first. So somebody grab your calculator for me. I need to know 5 to the 4th power, please. What is 5 to the 4th power? Five to the 4th power. $625, thank you. And then I have to multiply the 8 and the 625 together. What do I get when I multiply those two together? $5,000. All right, and then we come over here to this next piece. I need 5 to the 3rd power first. What is 5 to the 3rd power? 125. I have to multiply that by 4, and then we're going to subtract that. What is 4 times 125? 500. And then we come to the next piece. I need 5 squared first. What is 5 squared? 25. And then I need to know what 7 times 25 is. We're going to subtract that. 175. And then I do 6 times 5. What is 6 times 5? 30. And just bring that down right here. And that same thing with the plus 7 on the end here. I just bring down that plus 7 all the way. All right, all we need to do now is combine all these like terms together. So grab your calculator for me and combine those together. You should get 4,362. Nice work today, guys. Please make sure you have your test reviews with you tomorrow when you come to class. We're going to go over some more questions, and I'm going to make sure to highlight things that you absolutely have to know how to do. Have a great one, everybody. I'll see you tomorrow.